Welcome back to class. Today we are going to be looking at dimensional analysis. Alright, so you can see we have the fundamental quantities and their corresponding dimension. So for mass we have m, for the length we have L, for time we have T, for electric current we have A, luminous temperature we have K, luminous intensity we have CD, that's candela, and for amount of substance we have moles. Now to the derived quantities, because we are going to be needing them. So for area, we know that the formula for area is what? Is length times breadth. So I'm going to write it as the dimension of length times the dimension of breadth. Note, you must put this square bracket to show that you are talking about dimension. So what's the dimension of length from this place? We know that length is what? L times breadth, which is also length, L. So we have what? L squared. All right. So for volume, we have length, dimension of length times breadth times height. So I know that is going to give me what? L times L, which is L cube. So for the next one, we have what? We have density. We know that the formula for density is what? Is mass over volume. So I'm going to write it as the dimension of mass over the dimension of what? Over dimension of volume. So this has made it easier. I already know that the dimension of mass is m over the dimension of volume here is what? L cube. So I have L cube, which I can write as what? ml minus 3. So that is how to get it. The next one is velocity. What is velocity? I know that velocity is what? Displacement over the dimension of time. Note, you must always include the square bracket to show that you're talking about dimension. So displacement, when I talk about displacement, I know I'm also talking about what? Length. So my length, my displacement is L over time, which is what? Which is T. So I can write it as what? LT minus 1. The next one is acceleration. Acceleration, the formula for acceleration is velocity over time. Note, you must include square brackets to show dimension. So the velocity from here is already what? L over T divided by my time, which is what? T. So I have what? L over T times 1 over T, which will give me L over T squared, which is also the same thing as what? LT minus 2. We have for momentum. I know that momentum is what? Mass times velocity. So I'm going to write the dimension of mass times dimension of velocity. So dimension of mass is m times, what's the dimension of my velocity here? LT minus 1. So that will give me NLT minus 1. So the next one is what? Force. I know that force is what? Mass times acceleration. Dimension of mass is what? M times acceleration is what? LT minus 2. So that will give me what? MLT minus 2. So for pressure, pressure is what? Force over area. So what is our force from here? I know that my force is what? MLT minus 2. So I can write it as what? ML over T squared divided by what? Area. Area here is what? L squared. So I can say ML over T squared times 1 over L squared. So if I cancel this out, I'm going to have what? I'm going to be remaining with m over LT squared, which I can rewrite as what? M L minus 1 T minus 2. So the next one, which is what? Work. I know that work is what? The dimension of force times the dimension of distance. So from here, I know that force is what? ml t minus 2, that is my force, times distance. Times distance, which is what we know as what? L. So I know from here, L times L, I'm going to get ml squared t minus 2. So that is for work. The next one we have there is power. What is power? Power is work done over time taken. So I'm going to write it as dimension of work done over dimension of time. So from here, I know that dimension of work done is what? ml square over t square. Yes, divided by t. So that will give me what? ml square divided by t squared times 1 over t. So I'm going to have ml squared times 1 will give me ml squared over t cubed. So I can rewrite that as ml squared t minus 3. Alright, so the last one, we have our angle. So we can take our angle as arc length over radius. So what's my arc length? I know that my arc length is still talking about length is L over radius. The radius of a circle is also represented as L. So when L cancels L, I have it as 1. So I can say that my angle is what? Is dimensionless. Time for class tasks. Derive the dimension for impulse. Let me have your answers in the comment section. I'm Ganiat of the GP Effects Academy, and I will see you in the next class. Bye.